Okay, this is the Unit 4 test. 1 through 7 is graphing. So we're going to start with our equation that's already set up for graphing, which is set y equals its slope-intercept form. We know that the number by itself is our y-intercept. We know that the number with the x is our slope, and we always want it as a fraction, so when it's a whole number it's over 1. So it's positive, so we're going to rise 3, run 1. Now we can also go down 3, backwards 1. So there's that line. Okay, now the other line is in standard form, so you could solve for y, or you can just do your cover-up method and get your intercept. So if I cover up y to solve for my x-intercept, I would divide both sides by 3, and that would give me my x-intercept is -2. So on my x-axis, I'll put a point at -2. If I cover up my x, then I can find my y-intercept. Y would have to divide by -1, divide by -1, and that would cancel my negatives and give me a y-intercept of 6. Well, if you notice, that overlaps the other one. And remember, you can also find slope of opposite a, so -3 over b, which is -1, which is a +3 over 1. Well, if I go up 3 over 1, you'll notice it's all the same line. Okay, so when they overlap, we know that everywhere is a solution, so we call that IMS. And the kind of solution is dependent and consistent. Okay. Number 2, again, we're going to start with the equation that's already set up. So we have a y-intercept of +10, a slope of 3 again, but rise 3, run 1. Well, I can't go up 3, right 1, but I can go down 3, left 1. Okay. So when I cover up my y, it tells me x is 6, so I know my x-intercept is 6. So my x-axis, I'm going to put a point at 6. Then when I cover up my x to solve for y-intercept, divide by 2, I get 3. Okay, and then slope, if it's opposite of a, well, that's 1. So -1 over +2. So down 1 over 2. Down 1 over 2, and it worked. I can also go up 1, left 2, which is where I find our intersection. Okay, so the solution is where they touch, which is -2, +4. Okay, and the kind of solution is independent and consistent, because there's one solution and there is a solution. Okay, so this one is also set up in slope-intercept form. So -6 is my y-intercept. -3 over 2, so I'm going to go down 3, right 2. Down 1, 2, 3, right 1, 2. Can also go up 3, left 2. Okay, now on the other one, if I cover up y and divide both sides by 2, I get a half, and you can't graph that, so I'm not even going to write it down. But on this side, if I do divide by -1, divide by -1, I end up getting y-intercept is +1. Okay, and then I can still find my slope. So opposite of a is -2 over b is -1, which becomes +2 over 1, so rise 2, run 1. Now I can also go down 2, backwards 1, which is going to bring me towards my other line to find my intersection. So we'll see that they touch right here, which is -2, -3. And this is independent and consistent because it touches once. Now here we have Hooyvuk's. So this is a Hoy horizontal zero slope y equals equation. There's no x. Okay, so knowing that at y is 2, we're going to draw a line. Okay, and then this is a Vuk's equation, which is x equals with no y. So x equals -5 here. And they touch right here at -5, 2, which you'll notice is just those two numbers. Okay, and this is independent and consistent. Okay. Okay, so on this one, they're both in standard form, so it doesn't matter where you start. When I cover up y, I see that my x-intercept is -9. It tells me x equals -9. When I cover up my x to find my y-intercept, if I divide both sides by -3, well, -9 divided by -3 is +3. So I know I have a point on the x-axis at -9 and a y-axis at +3. And I also know my slope is opposite of a over b, which is a +1/3. So rise 1, run 1, 2, 3. Okay, so now the second equation, when I cover up y, I get my x-intercept is -4. When I cover up x, I get my y-intercept, we'll divide both sides by 2, I get -2. And my slope is opposite of a, which is just 1, so -1 over b, which is 2. So down 1, right 2. So -4 for x, -2 for y. And I'm going to go down 1, right 2, down 1, right 2, and also go up 1, left 2 to find where they touch. So my solution is this at -6, +1. And it's independent and consistent. Okay, over here I have this one that's already in slope-intercept form. So this is my y-intercept at -5. And my slope is -4 over 1, which means down 4, right 1. I can also go up 4, left 1. Okay. Now the other one's in standard form, so when I cover up y, I find my x-intercept is -4, because when I divide -12 by 3, I get -4. When I cover up this to solve for my y-intercept, divide both sides by -2, and I get +6. My slope is opposite of a over b, so it'll be a +3 over 2. Up 3, right 2. Up 3, right 2, up 3, right 2. So right away I see where they touch. And my solution is -2, +3. And again, it is independent and consistent. Now, number 7 is a little different. It's graphed, and it's asking you to find points. So I want you to remember that f of x equals y. So this is my x equals 4, and it's looking for y. So on my x-axis at 4, I go down, and I see there's a point at a height of -1. Okay, here at f of 2.5, 1, 2.5, well, you'll see that it's actually up, and it's at a height of 2. Okay, now you'll also see that this is telling me y equals -2. We don't know x, which is what's inside the parentheses. So at a height of -2 right here, I see that there's a point to the left 3, which means -3. And I had a +3, 1, 2, 3 is right here. And you'll see that I have a point left 2, which is -2. Okay, so down here is solving by substitution. So just a reminder, substitution is where you're plugging in. Well, nice thing is these two are actually already set up. I have y alone, which tells me x over 2 is my substitute. So I'm going to replace y with x over 2. So I get 2 times x over 2 equals x plus 4. Well, multiply and divide by 2 cancel each other. I get x equals x plus 4. I need to get all the x's on one side, so I'm going to subtract x. Well, when I end up subtracting, it cancels both. And I get 0 equals 0 plus 4, which is 4. Does 0 equal 4? No, so this is false, which means no solution, and it's inconsistent. Okay, and this next one, I get x is my substitute, 2y minus 1 is my, or 2y minus 1 is my substitute, so I'm going to replace x with my substitute, and I get 4 times 2y minus 1 minus 3y equals 21. 4 times 2y is 8y. 4 times -1 is -4. Bring down your minus 3y equals 21. 8y minus 3y, I'm going to combine my like terms, and I get 5y minus 4 equals 21. Add 4 to both sides, and I get 5y equals 25. Divide by 5, divide by 5, and I get y equals 5. So remember, that's half of my solution. Okay, so then I'm going to take it and plug it into the first one we messed with, x equals 2y minus 1, and I'm going to replace the y with 5. So I get x equals 2 times 5 minus 1, well 10 minus 1 is 9. So this is independent and consistent. Okay, on this one, we're going to solve for this y. So we're going to subtract 7x, subtract 7x, and we're going to divide by -1. I get y equals -36 plus 7x. So that tells me that this is my y and this is my substitute. So I'm going to replace y with the substitute. So I get 5x plus 3 times my substitute, negative 36 plus 7x equals negative 4, and I'm going to solve. So 3 times negative 36 is negative 108. 3 times 7x is positive 21x. I'm going to combine my like terms, and I get 26x minus 108 equals negative 4. I add 108 to both sides, and I get 26x equals 104. And when I divide both sides by 26, I get x equals 4. So again, that's half of my solution. And I'm going to plug it into, it doesn't matter which one, I'm going to pick the bottom one, 7x minus y equals 36. And I'm going to replace x with 4. So 7 times 4 minus y equals 36. Gives me 28 minus y equals 36. Subtract 28 from both sides. I get negative y equals 8. But I'm going to get rid of that negative by dividing by negative 1, and I end up getting y equals negative 8. And this is independent and consistent. Now, I haven't talked about this, might help if you can see, yet, but just a reminder to check your work in your calculator. So 5 times x, well, x is 4, plus 3 times y, which is negative 8, should equal negative 4, and it does. 7 times x, which is 4, minus y, which is negative 8, should equal 36, and it does. That's just proving that that is the right answer. Okay, number 11 is a little easier to set up because the x is positive, so all we have to do is minus 6y on both sides, and we get x equals 32 minus 6y. So we're going to replace x with our substitute, and we get 2 times 32 minus 6y plus 3y equals 10. 2 times 32, 64. 2 times negative 6y is negative 12y plus 3y equals 10. I'm going to combine my like terms, and I get 64 minus 9y equals 10. Minus 64 minus 64. I get negative 9y equals negative 54. Divide by negative 9, divide by negative 9, and I get y equals 6. So I know my y is 6. So then again, we plug into the original that we first messed with. So x plus 6y equals 32. And I'm replacing y with 6. So x plus 6 times 6 equals 32. Well, x plus 36 equals 32. Subtract 36 from both sides, and I get x equals negative 4. And this is independent and consistent. Okay, now these say solve by elimination. They're all in standard form, but they're not. Remember, our first step will be to make them have a 0 pair. So I always look at the smallest, like, variable, coefficient, whatever. Can 5 turn into 6? No. Can 4 turn into 8? Yes. By multiplying by 2. So I'm going to multiply 2 times 5x is 10x. 2 times negative 4y is negative 8y. And 2 times negative 26 is negative 52. I'm going to bring down that top equation. And I need to make sure these are a 0 pair. So one should be positive and one should be negative, and it is. So now we're going to do big addition. 10x plus 6x is 16x. Negative 8y plus 8y is 0. Negative 52 plus 20 is negative 32. Divide by 16, and I get x equals negative 2. So then I pick either equation, and I'm going to substitute it in. So I'll just pick the top one, and I have 6x plus 8y equals 20. I'm going to replace x with negative 2. So 6 times negative 2 plus 8y equals 20. Gives me negative 12 plus 8y equals 20. Add 12 to both sides, and I get 8y equals 32. Divide by 8, divide by 8, and y equals, why can't I think of that? 4. So this is independent and consistent. Okay, on number 13, we can cancel x's or y's. 4 can turn into 8, 3 can turn into 6. But if you notice, these are both positive and these are both negative. So let's cancel the y's. I need this to become a positive 6, so I'm going to multiply by a negative 2. So this gives me negative 8x, I don't know what I was about to write, plus 6y equals negative 44. And I'm going to just rewrite that bottom equation. 8x minus 6y equals 44. And right away when you do big addition, you should notice that everything zeroes out. And I get 0 equals 0, which is true. So this is IMS. Therefore, it's dependent and consistent. Remember, IMS stands for infinitely many solutions. If I were to graph this, it would be 2 lines right on top of each other. Okay, 14. 6 can't turn into 8 and 2 can't turn into 3, but my y's are smaller and one's already negative and one's already positive, and I know they can both turn into 6. If I multiply this one by 2 and this one by 3, I know that the y's will be a 0 pair. 2 times 8x is 16x. 2 times 3y is positive 6y. And 2 times 5 is 10. 3 times 6x is 18x. 3 times negative 2 is negative 6y. 3 times negative 9 is negative 27. So then I do my big addition. And this gives me 34. This zeroes out, and this gives me negative 17. So when I divide both sides by 34, I end up getting x equals negative 1/2, which if you wrote as a decimal is totally fine because it is a pretty decimal. I'm going to leave it as a fraction. So then I'm going to substitute it into either equation. I'm going to pick the bottom one. And I'm going to replace the x with negative 1/2. Well, half of 6 is 3, and then negative times positive is a negative. So I'm going to add 3 to both sides, and I get negative 2y equals negative 6. Divide by negative 2, divide by negative 2, y equals 3. So this is independent and consistent. Okay, we're going to skip number 15. Okay, for this system, combine the equations so that the y term is eliminated. So we want to make the y's a 0 pair. What can 5 and 3 both turn into? Well, they can both turn into 15. And I need one of them to be negative. So 5 times 3 is 15. 3 times 5 is 15. But one of them needs to be negative. It doesn't matter which one. 3 times 3x is 9x. 3 times 5y is 15y. 3 times 15 is negative 15. Oh, negative 45. Negative 5 times 2x is negative 10x. Negative 5 times 3y is negative 15y. And negative 5 times 4 is negative 20. So when we combine them, because it tells us to combine them, I'm running out of space. These cancel, and I'm getting negative 1x equals negative 65. And then divide both sides by negative 1, I get x equals 65. Okay, on the bottom it says for the system, combine the equation so that the x terms is eliminated. So we need 4 and 3 to eliminate. If we want to eliminate those, 4 and 3 can both turn into 12. Doesn't matter which one's which. And we're going to multiply this one by 3 and this one by 4. I'll do the top negative this time. 3 times 4x, I'm going to do it over here, is negative 12x. Negative 3 times 5y is negative 15y. Negative 3 times 7 is negative 21. 4 times 3x is 12x. 4 times negative 2y is negative 8y. And 4 times 34 is 136. So now we do big addition. This zeroes out. Negative 15 minus 8, negative 23, and 136, 115, divide by negative 23, I get negative 5. Okay, number 18. Which equation, when paired with the equation 2x minus 5y equals 10, creates a system with exactly one solution? So just as a reminder, the 3 different types or kinds of systems are going to look like this. You have no solution, which is inconsistent, and I want you to realize those have the same slope, but they have different y-intercepts. Okay, then you also have IMS, which also have same slope, same y-intercept because they're the exact same line. Then you can have something like this where they touch once and they have different slopes, and it doesn't matter about the y-intercepts. They could be the same, they could be different. The y-intercept could be your point. It could not be, okay? So the only thing that matters here is that they have a different slope. So I want you to realize the one with one solution is this one, and if they're going to touch with one solution, they're going to have a different slope. So we don't have to solve and make this 4 different problems. We can literally just find all of their slopes and see which one's different. So this one and this one are in standard form, but this one's in slope-intercept, slope-intercept, slope-intercept. So we already know those 3 slopes. So we really only have to find these 2 slopes. So I want you to remember M is opposite of A over B. So negative 2 over negative 5, which becomes positive 2/5. So this is my slope, and I want this one, whichever one's my answer, to be different. Okay, here is opposite of A over B, which is also a positive 2/5. So which one has a different slope? C, because its slope is just 2, while these are all 2/5, 2/5, 2/5. So A, B, and D could either be no solution or IMS, infinitely many solutions. Okay. Scroll so you can see it. 3 different systems of equations are represented below by their equation graphs and solution set. Write the letter for the best graph and solution set for each type, for each system of equations in the table. So, trying to figure out how I want to do this. We can solve them. I want you to realize too, you can find their slopes to know which ones do this. So let's do it that way. I know this first one has a slope of -1 over -2, which is a positive half. And the one on the bottom has a slope over -1 over 2, which is a -1 over 2. So they are different because this one's positive and this one's negative. So I know there's going to be one solution. Okay, here, if I divide everything by 3, I'll get that this is y equals 3x minus 3. And up here I can do my slope is opposite of a over b, so -3 over -1, which is +3. So I know these have the same slope. So it's either going to be infinitely many solutions or no solutions. So knowing that, my y-intercept here is -3, and my y-intercept here is -3, so these are the same line. So it's going to be f, which is infinitely many solutions. Okay, now on the last one, we obviously know what it should be. So these should have the same slope. Well, opposite of a is -1 over b is 2, so -1/2. This gives me -2 over 4, which is -1/2, so I know they have the same slope. And then y-intercept, you'll cover up x, divide both sides by 2. Well, that gives me a y-intercept of -2, and this one gives me a y-intercept of -3. So they're different y-intercepts, meaning e, which is no solution. Okay, number 20, it says 3 different systems of equations are graphed below. Identify each one with a description from column 1 and a description from column 2. So this is, I want you to realize it doesn't have arrows, but if you only see one line and I'm telling you it's a system, it's going to be 2 lines on top of each other, which means infinitely many solutions, which is consistent and dependent. Consistent because it has a solution, and dependent because they're all solutions. Now this one has no solution, and it's inconsistent because there's no solutions. Here has one solution because it touches one time, and therefore it's independent and consistent, which is E. Okay, a music store receives shipment of recorders and harmonicas. A shipment of 5 recorders and 4 harmonicas costs $62, and a shipment of 10 recorders and 3 harmonicas costs $84. Find the cost of a recorder and the cost of a harmonica. So I want you to realize right away it tells us we're looking for the cost of a recorder and the cost of a harmonica. And therefore, those are our 2 variables. So we can say R is the cost of recorder. You say H is the cost of harmonica. So this first one says a shipment of 5 recorders, so 5 times the cost plus 4 harmonicas times the cost equals a $62. And then 10 recorders plus 3 harmonicas cost $84. So right away I see that they're both in standard form, and I think elimination. And I also see right away that 5 can turn into a 10, but I want it to be a -10. So I'm going to multiply this first equation by -2. So this gives me -10R minus 8H. And then what does that give me? 62 times -2. It's -124. I'm going to rewrite 10R plus 3H equals 84. and I'm going to do big addition. These zero out, and I get negative 5h equals, so plus 84, negative 40. Divide both sides by negative 5, and I get 8. So harmonicas cost $8, but I still need to figure out how much a recorder costs. Okay, so it doesn't matter which equation we pick. I'm going to pick the top one, and I'm going to plug in what I know. So 5r plus 4 times h is 8 equals 62. 4 times 8 is 32. So I'm going to subtract 32 from both sides, and I get 5r equals 30. Divide by 5, and 30 divide 5 is 6. So I know recorders cost $6. Now, is this how I should leave my answer? No. When you have word problems, you should have word answers. So harmonicas cost $8, and recorders cost $6. I know there's not much space, so squeeze it in wherever you can. Okay, now let's look at number 22. Okay, so it says, at a professional basketball game, the turnstile count showed that 17,406 people paid admission. The total cash received for tickets was $133,372. Without actually counting the ticket stubs, find out how many paid for reserve seats, $10 each, and how many paid for general admission at $6 each. So I'm trying to figure out how many reserve seats and how many general admission. So we can say R is the number of reserved seats, and we can say G is the number of general seats. Okay? Oop, might help if you can see that. So knowing that, it says the total is 17,406. Well, I know R represents total, G represents total. So total plus total equals total. Now I know money is $10 for reserve, so 10R plus 6G equals 133,372. So money plus money equals money. So again, I think elimination, technically you could do substitution if you wanted. We'll do substitution strictly because change it up. So I could just subtract G from both sides, and I get R equals this. So I'm going to replace it here. And I get 10 times 17406 minus G plus 6G equals 13372. So when I multiply by 10, 174,060 minus 10G plus 6G equals 13372. So I'm going to combine like terms, and I'm also going to subtract this from both sides. And I get negative 4G equals 133,372 minus 174,060 is negative 40688, and I'm going to divide both sides by negative 4, and I get G equals 10172. Okay, I'm going to plug into the original because it's smaller numbers. So I know R plus G, which is 10172, equals 17406 minus 10172 minus 10172. R equals 17406 minus 7234. Okay, so I know there were 7,234 reserved seats sold and 10,172 general admission sold. Might help if I don't make one a part of my line.